All right. You are being asked to subtract two rational expressions, and that's just a fancy way of saying fractions. Um, let's say I had, that's too big. How about if I said, what if I had 4/5 minus, I don't know, 1/3, which is nothing but numbers, no variables. To do this, 5 and 3 are both prime numbers. They have nothing in common. So the common denominator would simply be multiplying them by themselves. So I'd take the 5 times the 3 and then the 3 times the 5. But what you do to the denominator, you also have to do to the numerator. So this becomes 12 over 15 minus 5 over 15. And once you get a common denominator, you subtract the numerators. 12 minus 5, that's 7, and the denominator stays the same. And then if you can reduce, you should. On this one, I can't reduce. But let's say that when I subtracted, it had been 6/15. Then I could actually divide both the numerator and the denominator by 3. And that would reduce it down to 2/5. Or some books will show, instead of showing division, they actually write it factored out. They write 2 times 3 over 3 times 5, and then they show you that the 3's cancel out, and there you're left with the 2/5. Okay? I'm going to do the exact same thing over here. When I look at my denominators of x plus 9 and x minus 3, they don't have any, they're like prime binomials. They don't factor. There's nothing you can factor from them. So I'm going to multiply the first one by the second one's denominator, and then the second one times the first one's denominator. Okay, so I'm going to have an x plus 9 times an x minus 3 minus, oops, the second fraction has the exact same denominator, and you can write it in either order, it doesn't matter. For the numerators, however, I'm going to take this 3 times an x minus 3, and that's going to be a 3x minus 9. And then over here, I'm going to take the 1 times the x plus 9, and that's going to give me an x plus 9. And once I have the denominators the same, just like I did up here, right? You get the common denominators. You subtract the numerators, and the denominator stays the same. So over here, let me erase all this. I'm going to subtract the numerators. So let's see, I'm going to take this 3x minus an x, and that's going to give me 2x. And then I'm going to go back and I'm going to take the negative 9 minus a positive 9, and that's going to give me a negative 18. And then the denominator, they have the same denominators here. The denominator stays the same. Now, once I do the subtraction, I should try to reduce my fraction. And in my numerator, I can actually factor out a 2, because if I take my 2x here and divide out the 2, I'm left with x. And the minus 18 divided by 2, I'm left with a minus 9. Now, it's too bad that that wasn't a positive 9, because then I could have canceled the x minus 9 with an x minus 9, or an x plus 9 with an x plus 9, but I can't, so unfortunately, that's my big old ugly fraction. Now, when I go back to Mobius, hang on a second. Okay, we're back in Mobius, and it says enclose numerators and denominators in parentheses. So it looks like that. The only problem is that our answer here has multiple sets of parentheses. So hang on, I'm going to do a split screen here. Okay, there we go. I just want to be able to see my answer. Since you have to put a 2 and an x minus 9 inside your parentheses, um, they've got this little thingy here. I prefer to use my fraction button. If you use this fraction button, you shouldn't have to use parentheses. Or not fraction button, the summation button. And then click on a to the b and put it as a fraction. And then I'd have 2 times x minus 9 over, and then get rid of that b, and then x plus 9 and x minus 3. There. If you use the fraction button and not use this backslash symbol right here, it makes it a lot easier. Because if you use the backslash symbol, you're going to have to use extra sets of parentheses or brackets. Let's see. Is it like my answer? Oh my gosh, why is it not taking my answer? X plus 2 times x minus 9 over x plus 9. Why? I don't know why they want. Oh, it shows it down here. They want extra sets of parentheses, which to me is redundant. So let me go back up here and put them in. This is totally redundant in my opinion. They shouldn't be needed. If it were in a textbook, you would never see this. It's like, what? I guess it's because they put it in their directions. Gotta follow whatever they say. It's kind of like having a boss that makes you go, what? What? Why does he want this? It makes no sense. Okay, now you're gonna like it? Ah! It still doesn't like it. What in God's name? 2 times x minus 9. I'm doing exactly what they want. Well, I am I'm confused. I don't think it's gonna let me do it one more time. My answer is correct. That is so bizarre. So bizarre. Well, it's giving me the how do you do? How did I do again? Well, don't give me the option. Let's do this their way. Let's see. Parenthesis, 2, parenthesis, x minus 9, parenthesis, parenthesis, backslash. Oh, then it did it there. Parenthesis, x plus 9, x minus 3. Close the parenthesis. I typed it in, exact. Now what? Oh, for the love of God. I've got it exactly the way they have it down here. Somebody shoot me. What in God's name? Do they want the multiplication signs? I can't. They cannot want this. This is getting ridiculous now. They cannot want that. Oh my God. You've got to be kidding me. Wow. I put the dots in and they liked it. That's just petty. Just total pettiness.